Okay, graphing polynomials. So, if you have a calculator, pull it out. And let's graph this x minus 3, x plus 2 squared. And you should get a graph that looks like this. From this graph, I can see that we have a 0 at negative 2, and we also have a 0 at 3. Okay, you could also get that from setting x minus 3 equal to 0, and you would get x equals 3. And x plus 2 equals 0, and you get x equals negative 2. Okay? So last time, when we were graphing, everything just would cross. Everything just crosses through. This time is a little bit different. So if you think back to the fundamental theorem of algebra, that talks about the highest exponent power, that's how many times, how many zeros you could possibly have. So if we look at this, we have, that's an exponent of 1, that's an exponent of 2. So 1 plus 2, that equals 3, which means we have 3 possible zeros. But since this is an exponent of 2, that just means that this 0 repeats itself. Okay, so it just touches right there. I'll get more into this. That's just kind of a very brief introduction. So there's our 2 zeros there. So let's look at this, and let's use technology to graph this first. So we have x minus 4 squared and x minus 3 cubed. So we get a graph that looks like that. Okay, we can set both those factors equal to 0. So x minus 4 equals 0, you get x equals 4. X minus 1 equals 0, you get x equals 1. So that's going to be 4, 0, and 1, 0. So that first 0, we're going to be 4, 0. That has a multiplicity of 2, because it's always just the exponent power. So whatever the exponent power is, that's your multiplicity. So that's a multiplicity of 2. And then if we look up at our graph, that's where 4 is, and it touches right there. So that's just going to be a touch. Okay, then we have 1, 0. That has a multiplicity of 3. If we look at our graph, it crosses right there. Okay, let's do another one. So we're going to ignore that 3 on the outside. There's no x with it, so we can just ignore it. There's our graph. Then we're going to set x minus 1 equal to 0 and x plus 2 equals to 0. So x minus 1, that equals x equals 1. X plus 2, x equals negative 2. So we have 1, 0, and negative 2, 0. So for 1, 0, that has a multiplicity of 2 because the exponent power there is 2 right here. Whoops. Right there. And if we look at our graph, at 1, 0, that is touching. So right here, that is touching. Okay? It doesn't go through it, it just touches it. And then negative 2, 0. That has a multiplicity of 1, and that crosses. So at negative 1, or at negative 2, it crosses. This is the important part. So even multiplicities touch. Odd multiplicities cross. Even touch, odd cross. Okay? You can try and come up with some stupid way to remember that. I literally just thought of this, and it's so stupid, but it might work. So this has 2 D's, this has 2 S's, odd, cross. If you can remember it that way, awesome. Just remember that even touches, odd crosses. Okay? So let's look at this, and we have to sketch this without technology. So if we factor the x squared minus 1, we could just square root both of these. So the square root of x squared is x, square root of 1 is 1. So that factors to x minus 1, x plus 1. So set each of those equal to 0. X plus 3 equals 0, x minus 1 equals 0, x plus 1 equals 0. So you get x equals negative 3, x equals 1, and x equals negative 1. So that's going to be negative 3, 0, 1, 0, and negative 1, 0. Negative 3 has a multiplicity of 2. 1 has a multiplicity of 1 because the exponent power there is 1. Negative 1 has a multiplicity of 1. Remember, even, touch, odd, cross. So that's going to be touch, cross, cross. Remember to sketch the graph. I literally wrote that right there so I wouldn't forget. So let's just draw a graph here. I know you guys don't have graphs on yours, so just draw it with me. So negative 3, 0, we're going to draw a point right there. 1, 0, we're going to draw a point right there. Negative 1, 0, right there. Now, we need to figure out, is this even, is this odd, what are my ends doing here? So I'm going to look at my, no, dang it, Lexi. Sorry. So, sorry, let's graph this again. Negative 3, 0, 1, 0, negative 1, 0. So we need to look at our exponents here to figure out if this is even or odd. So we have 2, we have 1, and 1. So that's going to be 2 plus 1 plus 1, which equals 4. There's not a negative out front, so this is even, and it is positive. Even and positive means that both sides are positive. If you can think back to that chart that we drew, that was like positive, negative, even, odd. If it's positive and even, they're both positive. If it's positive or it's negative and even, they're both negative. Odd and positive, it starts negative and ends positive. If it's negative and odd, it starts positive and ends negative. Okay, so this is going to be both positive. So this is going to end up, and this is also going to end up. Now, we're just going to go down this line right here. So touch, so this is going to be a touch. Here we're going to cross, and here we're also going to cross. Okay, so this is going to go down. It's going to touch that, go back up, cross there, and it's going to cross there. Okay, let's do another example. So this one, we have negative x plus 5 to the 4th, x minus 2 cubed. So we set negative x equal to 0, x plus 5 equal to 0, and x minus 2 equal to 0. So you're going to get x equals 0, x equals negative 5, and x equals 2. So that's going to be 0, 0, negative 5, 0, and 2, 0. 0, 0 has a multiplicity of 1, negative 5, 0 has a multiplicity of 4, and 2, 0 has a multiplicity of 3. So that's going to be cross, touch, cross. And then let's graph this. So let's start with drawing our points. So we have a point at 0, 0, and that is going to cross. We have a point at negative 5, 0, 1, 2, 3, 4, 5, and that's going to touch. And we have a point at 2, 0, and that is going to cross. We need to figure out what the ends are doing here. So let's figure out our end behavior. If this is a 1, we can just add all of this up together. So 1 plus 4 plus 3. 1 plus 4 is 5 plus 3 is 8. So that is even. And then we have a negative in front, so it's negative. So both the sides are going to be negative. So this is going to go down, and this is going to go down. Okay? And then this is going to go up, and it's going to touch that, come down, cross, and it's going to cross there. Cool? Okay, we have a couple more examples. Let's look at this one. So if you're given these parameters, let's sketch a graph. So we have a 0 at negative 3, 0, and a multiplicity of 2. So that one's going to touch. 0 at 4, 0, and a multiplicity of 3. That's going to cross. 5, 0, multiplicity of 1. That's going to cross. And it has a negative leading coefficient. We need to figure out if this is even or odd. So to figure that out, we just add up the multiplicities, just like we did in those past two examples. So that's going to be 2 plus 3 plus 1 equals 6. So that is even. And it's negative because they told us that. So it's negative and even, which means both sides are going to be negative. And then we can sketch this graph. Okay? I'm hoping this won't be too bad for you guys. I think you'll get it. So negative 3, 0, that's right there. 4, 0, 1, 2, 3, 4, and 5, 0. Negative 3, this is a touch. That's a cross, and that's a cross. We already figured out that they're both going to end negative, so this is going to be down, and this is going to be down. So that's going to be touch, cross, cross. Okay? Let's do one more. So negative 6, 0, multiplicity of 1, that's a cross. Negative 2, 0, multiplicity of 4, that's a touch. 1 plus 4 is 5, so this is an odd graph. And it's odd and positive, which means you start negative and you end positive. From that information, we can graph this. So we have negative 6, 0, 1, 2, 3, 4, 5, 6. And that's going to cross. Negative 2, 0, that's going to touch. And we start negative and we end positive. So this is going to cross, go down and touch, and just bounce right back up. Kind of like a bouncy ball. It's just going to touch it and bounce right off. Okay? That's it for this video. Sorry about my mistakes, but we fixed it. So we're good. Remember to take the quiz. You guys are super, super awesome. I love having all of you as my students. Okay, bye.